The motion detector's process is primarily to be a data collection, a very, very easy data collection tool for measuring distances. And one of the initial processes or the initial activities they do is they try to match their motion to a pre-recorded motion, and they get a sensing almost from a muscle memory or a kinesthetic sense that how things have to move in order to have the graph have a certain appearance. And the issue is that, or the advantage I should say, is that we get with this, is we get a sensing of this is what the motion is doing. So then when they see the motion of objects that they're recording, we'll take a look at that here in a little bit, is that they'll be able to actually say, oh, yeah, that motion is doing this, or it is not doing this. And what it allows the students to do is that they can make 7 or 8 graphs of motion literally in 30 seconds. And it's that graphing ability and that quick analysis and the what-if scenario. Well, what if I walk a little faster? Well, rather than waiting for 30 minutes to replot a whole new set of data points, the points are already there by the time that they finish that motion. This particular project that I'm putting through is the end of a fairly long unit on linear motion in my physics class. And I'm a firm believer in using real life and moderately messy data gathering kind of events. And so I use the action scenes out of movies as my prompt or as my source of this data. And built in within the Logger Pro setup is the ability to do video analysis. And video analysis merely is taking the picture like you see here up on the screen, and through a series of tools they're able to figure out what is going on. So the first thing we do, we're going to sit here and we're going to put a axis system on here, and then we're going to collect some data. And we can say, move this out of the way here. And so we're just going to select all the data, come up here to a curve fit, choose our axis, and that's how easy that particular process is. I notice here that I've collected this range from 2 to 9 on my time scale. So I have about 3/10 of a second that I have collected. And so I take my 3/10 of a second, divide it into this, and I come up with my acceleration for that particular event. Well, I know all of my students are going out into the world, the military, the academic, and the corporate world. And in every one of those environments, there is a high use of technology. If you look inside of any armored vehicle nowadays, you are going to get computer screens, touch screens. You're going to get digital positioning. You take a look at the corporate world. They're doing live meetings. They are doing moving data back and forth. They're doing cloud computing. And if you get in the academic world, Texas School of Business in Austin, they have their 5,000 students, and they are in a virtual computer environment. They do not have paper. Everything is done electronically. The students have to learn how to manipulate this stuff someplace. And folks have a choice. They can spend their $2,500 a credit at a college and get trained with this, or they can get a low-paying job initially and get trained up in it, or they can walk out of my classroom and say, oh, I have these skills in PowerPoint, in Word, in video analysis, in electronic resubmission. I can